Hello class, my name is Ian Satoda. We'll be going over Euler's method and Calculus BC FRQ 1999 number 6. So in order to find the tangent line of f at x equals 3, we first have to find the slope at x equals 3. So we plug 3 into our derivative right here. So f of 3 equals 1 plus e cubed over 9 if we plug in 3. And that should equal, I'm going to put this in purple, 2.342. And so this is our slope of our line. And if we plug that into our point slope formula, so you get y minus y1, which is 6, equals our slope here, 2.342, times x minus our x1, 3. So I'm going to put this in slope-intercept form. So y equals 2.342 times x minus 3 plus 6. And to approximate 3.1 for the second part, we simply have to plug in 3.1 into our x. So f of 3.1 equals 2.342 times 3.1 minus 3 plus 6. And if we plug this into our calculator, we should get our answer to be 6.234. There's not really any tricks for this question. It's pretty much just simple math and plugging in values. For A, you're going to be graded on plugging in 3 to the slope, using the equation of y equals mx plus b, basically the linear approximation, and finding your approximation, or basically your answer. So for the next part of the FRQ, we're going to use Euler's method. Now, we just do exactly what we did in the first part, in part A, with linear approximation, but we pretty much just do it twice. For the first step, to find f of 3.05, since that's our step size, we make that f of 3, which is our y value, plus the derivative of f at 3, times our step size, which is 0.05. Now this linear approximation follows the form of y equals mx plus b, where this is our slope, this is our step size, our x, and this is our plus b. So f of 3 is 6 plus our derivative of 3, which was 2.342, times 0.05. So if you plug this into your calculator, this should get you 6.11714. Now to get f of 3.1, we just do the same thing, but with our new numbers that we got, 3.05 and 6.12. So that equals 6.11714 plus the derivative at 3.05, which is the slope, times our step size. So this equals 6.11714 plus 2.37735 times 0.05. And if you plug this into your calculator, your final answer will get you 6.236. For the next part of part B, we need to use the second derivative to explain why the approximation found is less than the actual value of f of 3.1. So first we have to find this part. In order to do that, we have to find the second derivative. And to do that, we just use the quotient rule, but I think everyone knows how to do that already at this point. So I'm just going to write out the second derivative, which equals x minus 2 times e to the x minus 2 over x cubed. For the approximation to be less than the actual, the graph of f has to be concave upward, which means that the second derivative has to be positive. Therefore, we're testing to prove that the second derivative at 3 is positive, so it has to be greater than 0. This graph gives a visual way of looking at the second derivative. At x equals 3, the line is greater than 0, which means that f is concave up. For part B, you're going to be graded based on your use of Euler's, finding the correct approximation, getting the second derivative, and correctly reasoning why the approximation is less than the actual value. Part C asks us to use the integral from 3 to 3.1 of f prime of x to evaluate f of 3.1. Now, this integral right here will give us our f of x value when it's f of 3.1 minus f of 3. We already know that f of 3 is equal to 6. So we just take the integral of here and add it to our f of 3 value. So f of 3.1 equals f of 3 plus this integral. And if you plug this into your calculator, given the f prime of x, you will get 0.2378. And f of 3 we know is 6, so you just plug in 6 plus 0.2378, and your answer will be 6.238 if we round to the third decimal. It's important to remember that f of 3.1 is not equal to the integral from 3 to 3.1, but you have to add it to the previous f of 3. For this particular question, you're going to be graded on your ability to integrate the integral given and find the correct answer. So in this one, there's not much to really worry about. Just show all your work and you'll do great. Well, that wraps up this video. Thank you to everyone who watched until the end. You guys are the true homies, and you're the reason why I continue living. Absolutely love you guys. I don't even have to say good luck to you guys because I know you're going to absolutely ace this next test, you know. You can thank me later. Shout out to Uncle Jimmy for teaching me this material. Now I can pass on this information to all of you. I got a little sample problem that I might link in the description, maybe not, depending on if I know how to use YouTube or not. Not really sure how that goes, but I probably will. We'll see. Check it out. It's good practice, though. Come back for my next video where I'll teach you my multiple bread eating techniques. You know, you can toast it, bake it, microwave it, eat it plain. I mean, your choice. Sometimes it's good to just eat it plain, you know. Yeah. Please give me an A on this. I need it.